Circle Properties Practice Part 1. Now we have already completed question 1, 2 and 3 in the previous exercises. So now we're going to start with question number 4. In this question, the diagram here, O is the center of the circle. Now the moment we have center of the circle, what do we notice? Number 1, we have angle at center twice angle at circumference. And I know that OB is a radius, OC is also a radius. So what does that tells me? I have here to be 40 degrees as well. Next, I have TB to be a tangent. So T to B is a tangent. And at the angle B. The diameter AC, so I have a diameter. When I have a diameter, that means I will have a semicircle. Angles in a semicircle are 90 degrees. So in that case, I will have a semicircle, a right angle over here. If this angle is 40, that means this angle over here will be 50. Okay. And now they tell me a certain number. I have the angle here 32. Now what other shapes do I observe? Do I see the angles at center twice angle at circumference? And I also see angles in semicircle. Do you see any angles in the same segment? The butterfly? Yes. I have a butterfly over here. I may need it later. Alright, then let's begin with the question. Questions ask us to find angle ABT. Now we already know that angle OBA is 50 degrees. Right, so we're going to write for part 1. First, number 1, we know that angle OBA is 90 minus 40 degrees. That gives us 50 degrees. Then therefore, as a result, if I want to find angle ABT, it will be 90 degrees minus 50 to give me an angle of 40 degrees for this angle over here. Next, find angle OBE. In order to find angle OBE, which is the angle over here, I will need to look at the following triangle. DBC. In this triangle, I know that the angle here is 32. This is 40. This is 40. I'll need to find this one. That means the remaining angle that I need to find is actually this angle over here. Now this angle is angle at the circumference. Angle at the center is twice the angle at the circumference. So what do we do? In this case, for part 2, we know that angle at the center, BOC, is 180 degrees minus 40 to give me 100 degrees. If that is the case, angle CDB will now be the angle at the circumference, which is 100 divided by 2 to give me 50 degrees. Now using triangle DCB, I want to find the angle OBE. That will be 180 subtract 50 minus 32 minus 40 minus 40. And that gives me the answer 18 degrees. Next one, part 3. I'm going to find what is angle BAD. Now, where is angle BAD? Oh, angle BAD is over here, where I need to draw a straight line joining B to A, D. Now, what do we notice? We have D, A, B, and C to be 4 points on the circumference. That means this will be a cyclic chord. If we were to have a cyclic chord, the angles in the opposite segment add up to 180 degrees. So therefore, angle BAD will be 180 minus 32 minus 40 to give me the answer 108 degrees. Next one, I need to find the angle CED. I have seen that in the triangle CED. This is 50 degrees. This is 32. Therefore, angle CED will be 180 minus 50 minus 32 degrees to give me a total of 98 degrees. Have you gotten the answer? Question number 5. A, B, C, D are points on the circle. Now you notice that you have 4 points here. Therefore, they will become a cyclic chord. Okay. And next one, they tell us that TA and TC are tangents to the circle. Now they are tangents from an external point. That means these two lines will be equal. And what do you notice about triangle ACT? Triangle ACT is an isosceles triangle. And then they give us a couple of different angles over here. I have this angle to be 70 degrees. That means the angle ABC here will be 110 degrees by angles on a straight line. And what other information can I find? I see a butterfly. I also see angles in opposite segment, the cyclic chord. Right, now let's begin with our question. Question number 1 asks us to find angle CACB. So this angle over here. I noticed that triangle ACT is a isosceles triangle. How can I find the angle ACB? Number 1, using angles of isosceles triangle. Angle ACT is actually 180 minus 40 divided by 2. That gives me 70 degrees. If that's the case, then I'll be able to find angle ACB to be 70 degrees minus away 45. I get the answer of 25 degrees. Next, the question asks us to find angle ADC. Now, angle ADC is over here. We know that angle ADC and B actually forms a cyclic chord. So if this angle is 110, what will be angle ADC? By angles in opposite segment, angle ADC will now be 180 minus 110. That gives me the number 70. Last but not least, let us find out the answer for part 3, angle BDC. Now, in order to find BDC, I noticed that it's being cut into a couple of lines. Now, we have a butterfly over here. That means angle 25, this angle here will be also 25. So if I want to find angle BDC, that leaves me with 70 minus 25. Now let us write down our properties. So the first step was that we are able to identify the angles in the same segment, the butterfly. ADB is actually 25 degrees. If that's the case, then angle BDC that they want will be 70 minus 25 degrees. And that gives me 45. Have you gotten the answer? Question number 6. In the diagram, PR is a diameter. Now, diameter can mean a lot of things. If I have a diameter, I will have angles in a semicircle to be equal to 90 degrees. That means angle PSR here will be 90 degrees. If that is true, then what will this angle over here be? This will be 90 minus 55 degrees, and it gives us the answer of 35 degrees. Next, we know that Q and S are on the circumference. The tangent to the circle at the point P meets RS at the T produced. Now I have a tangent. So tangent is perpendicular to radius, meaning that this will be a 90 degrees. And what other things do I know? Okay, I know that I have points on the circumference, Q and S, and maybe I can see the shape of a butterfly, the angles in the same segment over here. Now, let's take a look at the questions that we are going to solve. They ask us to find angle PRQ. Where is angle PRQ? Oh, PRQ is over here. There is a butterfly, angles in the same segment. So therefore, number 1, angle PRQ will be 55 degrees by the property of angles in the same segment. Number 2, find the angle PTR. What do we notice? Which triangle have angle PTR? Well, this triangle PTR over here. We know that this is 90 degrees, this is 22 degrees. That means the angle PTR will be 180 degrees minus the other two angles. So we have 180 minus the 90, the tangent, minus 22 degrees. That will give us an angle of 68 degrees. Next one, part 3. We need to find the angle RXS. Where is the angle RXS? Over here. It can be seen very clearly. We have the triangle R, X, and S over here. So in this triangle RXS, we have angle sum of triangle. This will be 180 degrees minus 22 degrees and minus the answer that we have found, 35 degrees. Now when you write this in exam, okay, this working is shown on your paper, so they'll be able to read and give you the marks as well. So this answer here will be 123 degrees. Have you gotten the answer? Question number 7. O is the center of the circle. Now when this is the center of circle, what property can you think of? Well, we can think of the Chinese answer. Angle at center is twice the angle at the circumference. Where is this angle at the center? Angle at the center here. I have the two anchor points D and A. These two legs here, then this Chinese answer do a split. Where can they go to? They can join to the circumference over here. And this is the angle 28. That means this angle over here, DOA, angle DOA, will be taking 28 degrees times 2 to be 56 degrees. And next one, they say AC is a diameter of the circle. Now we will have a semicircle over here. So we can see a semicircle diameter. And as a result, angles in semicircle are 90 degrees. That means this angle over here will be taking 90 degrees minus 28 degrees to be 62 degrees. And then they tell us that A is the tangent to the circle. That means we will have a 90 degree over here. And this angle over here can be found to be 90 degrees minus 53 and give us 37. Now we have found basically some of the questions that we can get. Let us answer the question one by one. Part 1. Find the angle AXB. In order to find the angle AXB, I've gotten this number to be 37 and this is 28. So angle AXB will be 180 minus 37 minus 28. That gives me an answer of 115. Part 2. Find angle AOD. Well, angle AOD is down here. Angle at the center is twice the angle at the circumference. So in this case, I will have angle AOD to be 28 times 2, which is 56 degrees. Part 3. Find the angle ADB. Where's this angle ADB? Maybe you need to draw a new line. Angle AD to B. Now what can I do with this line AD? Now they ask me to find angle ADB. In that case, I can actually form a butterfly over here, angles in the same segment. Angle ADB will be equals to angle ACB. And we know from here, we have this angle is 37 degrees. We have this whole thing to be 90 degrees. Are we able to find this angle? Yes. So that's the case. We shall say angle ADB is actually equals to angle ACB by angles in the same segment. And angles ACB can be found using the triangle ACB, where I have 180 degrees minus the angles in semicircle, 90 degrees, minus the angle that I found, 37 degrees. And that gives me an answer of 53 degrees. Have you gotten the answer? Question number 8. The circle BCDE has center O. Do you see a Chinese dancer? Angle at center twice, angle at circumference. Okay, and then next, they tell us that AB and AC are tangents to the circle. That means I will have a 90 degree over here, a 90 degrees over here. And we know that this is a quadrilateral over here, OC, A, and B. Now, angles in a quadrilateral are 360 degrees. Subtract away 90, 90, and 56. I'll be able to get this angle, right? And now they tell me OCFE is a straight line. This is a straight line that passes through the center of the circle. So this means this is a diameter. If I have a diameter, I should be able to get angles in semicircle to be 90 degrees. Now, we have done some analysis. Let us begin with the question. Part A. Give a reason why angle OBA is 90 degrees. It's a right angle. Oh, because its tangents is perpendicular to the radius. Part B. Given that CED is the angle 65 and I have CAD to be 56, find the angle BOC. Well, angle BOC, we can use the angle sum of a quadrilateral. 360 degrees minus 90, minus 90, minus 56. Then that will give us the answer 124, 124 degrees. Next up, find angle BDC. Where is this angle BDC? Angle BDC is angle at the circumference. So if this is the angle at the circumference, we can link it to twice to the angle at the center. Angle at the center is twice the angle at the circumference. So that means for part 2, angle BDC will now be taking the angle at the center 124 divide by 2. And that gives us 62 degrees. Next, they ask us to find the angle OFD. Where is the angle OFD? Oh, OFD is down here, this angle. I can see quite clearly that O and OF, D, and C is actually a triangle. Now we already know that EDC is a right angle triangle where this is 90 degrees. If this is also 65, can I find the angle ECD? So number 1, first step, I'll probably find angle ECD first. Angle ECD will be angle sum of triangle 180 minus the right angle, angles in semicircle, minus the 65 degrees that's given, and that will be the number 25. So after I know that this is 25 degrees, now I can find number 2, angle OFD. Angle OFD will now be 180 minus the angle at the circumference 62 minus the one we just found, 25 degrees, to give me the answer 93 degrees. Have you gotten the answer? Question number 9. In the diagram, AC is a diameter. Now when we have a diameter, what will we have? AC is the diameter. That means I will get a semicircle over here. Angles in semicircle are 90 degrees. And similarly, angles in semicircle over here, this is also 90 degrees. Next, they tell us that we have straight lines cutting the circle. So I can actually see a big triangle ADE, right? And I know that AD is already 90 degrees. And I know a particular angle, probably can find angle E later, right? And let us take a look. What other pictures do I see? Do you see a butterfly? We have a couple of butterflies down here, angles in the same segment. Now, probably we need to use them a bit later. Now, let's take a look at our question. They ask us to find angle BCD. Well, angle BCD over here, I have 4 points on the circumference of a circle. It forms a quadrilateral, a cyclic quad. So therefore, we can have angles in opposite segment to add up to 180 degrees. So part 1, angle BCD will be 180 degrees minus 31 minus 42. And that gives me 107 degrees. Next, let us find angle ABD. Angle ABD over here is the same as I see the butterfly angle over here. So angle ABD is actually equals to the angle ACD. So inside the triangle ADC, I have a 90 degrees, I have 31, I can find this angle. So angle ABD will be equals to angle ACD by the property angles in the same segment. And it's now equals to 180 minus 90 degrees minus 31, angle sum of triangle, to give me the answer 59 degrees. Part 3. Find the angle CFD. Where is the angle CFD? CFD is over here. This is vertically opposite angle BFA. If that's the case, we can use angle sum of triangle for triangle ABF. So I know that angle CFD is vertically opposite equals to angle BFA. And BFA can be found by 180 degrees minus 42 minus 59 degrees. And that gives me 79 degrees. Next one, they ask us to find the angle AED. Well, triangle AED itself is the big triangle. I already know that ADC is 90 degrees and this is 31. Therefore, by angle sum of triangle, it will be 180 minus 90 minus, oh no, the whole of this angle, 31 minus 42. So give me the answer 17 degrees. Have you gotten the answer? Last question for the day. The points A, P, Q, B are lines on the circle. Well, you can see that this one here, we have a cyclic chord. Now, let's look at some information that we can find. I can see that this angle here is 69, and angles on a straight line will tell me this angle will now become 180 minus 69. I'm not sure whether do I need to use it later, but probably I'll need to use it soon. So I just write it down first. Okay. Then they tell me that AP is being produced to R. Okay. And I have the angle 24 and the angle 21. Now let's take a look at some of the pictures. We do not have the center of circle, so we do not know anything about semicircles. But can we have a butterfly, angles in the same segment? Well, yes, there is angles in the same segment over here. Do you see this butterfly? So if that's the case, this is 21 degrees. That means the angle over here is also 21 degrees. Well, I may need to use it later. I wouldn't know. Now, let's take a look at our questions. Question asks us to find angle QPB. Oh. There you have it. Stating your reasons clearly. Now, this is the butterfly. That means it's angles in the same segment. So, angle QPB is equals to 21 degrees. Angles in same segment. Part B. Given that M is a midpoint of AB, so somewhere in the center, does it look like M is the center of the circle? But the question is, did they tell me that AB is a diameter? No, right? So that means I will need to find something else. Let's take a look. They want to find the angle PMA. Oh, it does look like we want to find angle at the center to be twice angle at the circumference. But in the first place, I do not know whether is AB the diameter, so I cannot assume. Now, what other numbers do I have? I noticed just now I wrote down angle QPA is equals to 180 degrees minus 69 to be equals to 111. And I know from part A that the angle QPB is 21 degrees. So what does that mean? What can it give me? What is the angle BPA over here? This angle will now be angle BPA, sorry. To be 111 minus 21 degrees, which gives me 90 degrees. Now, since this is a 90 degree, angles in semicircle are 90 degrees. What can I say about AB? AB will be the diameter. Since M is the midpoint, therefore, M is the center of the circle. Now, if I know that M is the center of circle, angle at center is twice the angle at the circumference. So I'll see a Chinese dancer, angle at the center with the anchor point of the legs at P and A. It now stands up to touch the circumference at B. So this angle at the center, angle P and A, is now 2 times the angle of circumference, which is the angle 48 degrees. Have you gotten the answer?